All right, our last scientist of the combined gas law is Amadeo Avogadro. Yes, Avogadro from Avogadro's constant. So our mole guy, of course, studied the mole, and so he studied the mole and volume. So mole and volume. Moles, which is the amount, and volume, the amount of space it will take up. And so basically he said that if you, so what did he keep constant? Let's go ahead and put that. So pressure, not part of it, and temperature. Okay, they stay the same. So part of that combined gas law. So he said basically if you had 1 mole of a gas and if the pressure and temperatures was the same, if you put twice as much, then it's going to get twice the volume. So say this was maybe 100 milliliters. Now this would be 200 milliliters. Make perfect sense. Okay, so this is a direct proportion again, so these are directly related. So the only one that is inversely is Boyle. So all the rest of them, if one goes up, the other thing goes up. So if you increase the moles, which is your letter N in the problem, if it goes up, your volume is also going to go up. And if your moles goes down, your volume is also going to go down. Perfect sense on this. So his law looks like this. If you think of where the formula is, it's V1 over my little thing over N1 equals V2 over N2. So very easy, but these do require a little bit of reading comprehension. So let's look at the problem. So I've put this on here, but if you have 1 mole of gas, it will always at STP have a volume of 22.4 liters. Doesn't matter what gas you got. 1 mole of them, those number of particles, hydrogen, helium, carbon dioxide, will always have a volume of 22.4 liters. Some of you might have used that number in high school. Unfortunately, most of the time our gases are not at STP, so we're not going to really use that number, but it is a true statement. I used to have a beach ball that was that size to illustrate what 22.4 liters was. All right, so let's look. It says a 5-liter container of gas, so we've got 5 liters is our volume, is known to contain, so we've got 0.0, whoops, put my 0 in the wrong spot. Having some writing issues here. So we got moles of some gas. I don't know what gas it is, so I won't put my label there. So it says if the amount of gas is increased by, this is important. It doesn't say that this is the new mole, which is some of you just want to do that. You got to actually read the problem. It increased by, so what it means was, well, it was this, but I added this much to it. That's what some of you weren't reading on your your dilution problem. So my total here is 1.8 moles. So almost double this. I want to know what the volume would be. We're keeping the pressure and temperature the same. So you've got V1 over N1 equals V2 over N2. You've got 5 liters on top and 0.965 mole on bottom. On this side, V2 over 1.8 mole. Again, I would cross multiply and then I would divide. So I would multiply 5 times 1.8 and I would divide by 0.965. That is not the way you have to do it. So you should find that your new volume has almost doubled to 9.33 liters. You put more gas in it, it is going to take up more space. That is Avogadro, so please make sure you're careful when you read those problems and see if you're adding to it or if that's the new amount of moles. Sometimes you might have to take your grams and convert them to moles. That gets a little tricky. All right, see you on the next video.